Hey guys, this is test 66 game 1. This is the lab assistance game. It's an ordering game. We know this because we have Wednesday, Thursday, Friday, and morning, afternoon, and especially because the final rule of the game is telling us that J is appearing earlier than O. So for that reason, we know we're ordering these 6 people, J, K, L, N, O, and R, over the course of the 3 different days. Now, we have a couple of rules here. I've laid them out. Don't worry, though, I'll explain all of them. The first rule tells us that K and R are going to be on the same day, so I place them in a vertical box here. We don't know whether we're going to have K or R on top and then R or K on bottom, so it could be K on top, R on bottom, or R on top, K on bottom. Next rule tells us that O and L cannot be on the same day, so we're never going to have them vertically together. We know that N has to be in the afternoon, and we know that J is before O. So for that reason, we can infer that O is never Wednesday, and J is never Friday, and this is our initial setup for the game. Not a whole lot to do in the way of inferences. We're going to be doing more of that over the course of the game itself. Now, question number 1 is our typical orientation question. We're just going to want to take one rule at a time and apply that rule to all 5 choices, looking for violations. So to start, we could take the rule that N is always in the afternoon, meaning N is never in the morning. So any choice featuring N in the morning must automatically be eliminated. So for that reason, we can get rid of choice A, which has N in the morning of Friday. All the other choices are good on that issue. So we can move on to another rule now, like J must go before O. So scanning through the choices, we see that O is before J on choice B, having O Wednesday, J Thursday, unacceptable. For that reason, choice B is eliminated. Next, choice C. Next, we could take the rule, for example, that we always have to have O and L on different days. They can never be on the same day. Scanning through the choices, we find that they are together in choice D, where we have O and L on Friday, unacceptable, so D is eliminated. Down to C and E now, we can take the rule that K and R must always be on the same day. Choice C is violating that, with K on Wednesday yet having R on Thursday, unacceptable. C is eliminated, leaving E by process of elimination for number 1. Next, number 2, if L does not go on Wednesday, what must go on Thursday? So if L is never on Wednesday for this question, we can put down L with a slash through it below the Wednesday level. This means that O and L must be spread across Thursday and Friday because they never go together on the same day. So because they're going to be spread across Thursday and Friday, we're going to have K and R on Wednesday in order to fit them together within the very same day. So now we've got O and L on Thursday and Friday in some combination, except because Wednesday is full, we must have J on Thursday and O on Friday in those columns in order to maintain the J before O rule, although we don't know specifically whether they are going in the morning or afternoon on those days. So not a whole lot to infer here, but enough to answer the question, because they're simply asking us who must go on Thursday. And the answer, of course, is J. We also know that L will have to go on Thursday because O is Friday, so we could put down L above the Thursday level as well, although we don't know whether J's in the morning or L's in the morning or vice versa. But of course, L is not a choice, while J is, so for that reason, E is our answer to number 2. Next, number 3, they're asking us if K goes immediately before N, although not necessarily also in the afternoon. So we've got some kind of K-N combination. I'm putting them in a box, although of course, remember that K could be in the morning, while N is always in the afternoon, of course. So 2 different ways that could play out. Either we have N on Friday afternoon and K on Thursday, or we have N on Thursday afternoon and K on Wednesday in some combination. Now, of course, K and R are a pair. They go vertically together, so I'm going to put down K/R on Thursday for the top diagram and R/K on Thursday afternoon. Then on the bottom diagram, we've got K/R Wednesday morning, R/K Wednesday afternoon. Now, what else can we fill in? Well, we know that J's got to go before O, right? So for that reason, we have O on Friday morning in the top diagram, and we have J on Thursday morning in the bottom diagram. Then in the remaining slots, we basically have, J slash L, L slash J on Wednesday for the top diagram, and we have O slash L, L slash O in the bottom diagram. Now, those of you who've been paying close attention here will remember that O and L have a vertical not box here, right? We know that O and L cannot be together on the same day. So for that reason, we actually have to reject this bottom diagram as being invalid, and we're only going to make use of the top one here. The bottom diagram is bad because it violates that rule. We're going to use only the top one here. Now, a complete and accurate list of people, any one of whom could be on Thursday afternoon. Well, we know that R and K are basically the only two people who could be on Thursday afternoon. Nobody else is good. So for that reason, we've got B as our answer for number 3. Next, number 4. I'm going to keep these two diagrams here simply because I'm going to make use of them as I explain number 4. Now we've got J and K both in the morning here, and J's before O. So for that reason, we could either have J on Thursday morning, or we could have J on Wednesday morning, and these are going to be my two main diagrams for this question. Now K will also be in the morning. Of course, we don't know exactly where, so I'm going to put down K next to the morning row. Now we've got N in the afternoon as always, so we've just got O, L, and R remaining. Now we know that K and R have to be together on the same day according to one of our rules, so R will have to go in the afternoon level, although we don't know specifically where it will go. Then we've got O and L remaining, and we know that they cannot be on the same day, so they will have to be split simply because we've already got 2 on the morning and 2 on the afternoon for both of these. There's not room to have O and L be on the same level. So I'm going to put down O slash L and L slash O for our remaining slots here. Now because J is before O, O will have to go on Friday in the top diagram. So for that reason, we have K and R interchangeable on the Wednesday level specifically, on the Wednesday column specifically. They could not both be in Friday because if they were, we would not be able to fit O there as well. So on the top diagram, we've got things pretty filled in right now. We know that O has to be on Friday somewhere, and it cannot be with L. So for that reason, L will have to go on Thursday, and then we will have N Friday, because N has to be in the afternoon. It will be on Friday afternoon in particular, and we are left with O on Friday morning. So this diagram is pretty filled in. We could look at the bottom one, but because they're just asking us could be true except, let's try to eliminate some choices based on the diagram that we've built here. So could we have L on Wednesday morning? Haven't seen it, so we'll keep that for now. Could we have L on Thursday afternoon? Yes, we certainly could. We see it right here. So for that reason, B is eliminated for number 4. Next, choice C, N on Friday afternoon. Yes, we do have that right here, so C is gone. O on Thursday morning. Haven't seen it, so we'll keep that for now. And then E Friday morning. O on Friday morning, yes, we see that as well. So E is eliminated. We're already down to A and D. Now let's explore the bottom diagram. Now for the bottom diagram, same thing as the top, we've got O and L split just because there isn't enough room to have both of them on the same level. Now this one becomes a little bit more ambiguous because we gotta have K and R vertically on the same day, but that could happen on Thursday or on Friday, and we've got to have O and L split. So for that reason, we cannot say exactly where those guys will go, but it's either KR Thursday, O somebody else Friday, or KR Friday, O and somebody else Thursday. Thing is, we know exactly who that somebody else is. That somebody else will be N, meaning that N has to be on either Thursday or Friday, cannot be on Wednesday. So we've got to have L on Wednesday. And then we're either going to have K and R Thursday, O and N Friday, or K and R Friday and O and N Thursday. So for that reason, being that we're down to A and D, we see that L on Wednesday morning certainly is not happening. L is specifically Wednesday afternoon in this diagram and specifically Thursday afternoon in the top diagram. So A is our cannot and is our answer to number 4, whereas D, saying O on Thursday morning, that could certainly happen. We could have O on Thursday, we could have N on Thursday afternoon, and then K and R interchangeable on Friday. Next, number 5, if J is Thursday afternoon, so let's right away put down J on Thursday afternoon and make some inferences about what else will happen. J is Thursday afternoon, O will have to be Friday, meaning there's no room for K and R on Friday, so they're going to have to go on Wednesday, interchangeably, of course. We never really get to determine specifically where they are. And then we're going to have N on the remaining afternoon slot, forcing O into Friday morning so it can go after J, leaving L on Thursday morning. So they're asking us here, for how many other people can we determine exactly where they go? So we've got L specific, O specific, and N specific. Of course, we've also got J specific, but they're asking us how many other, not how many total. So for that reason, our answer is 3 other, choice C, and 4 people total. But 3 others what they're asking for, so C is our answer to number 5.